Third law of thermodynamics. At absolute zero, the entropy of a perfectly crystalline substance is zero, which means that at absolute zero, every crystalline solid is in a state of perfect order and its entropy should be zero. By virtue of the third law, the absolute value of entropy, unlike absolute value of enthalpy for any pure substance, can be calculated at room temperature. St minus S naught K is equal to integration 0 to T Q reversible upon T. Since S naught K is equal to 0, St is equal to integration 0 to T Q reversible upon T. Absolute entropies of various substances have been tabulated, and these values are used to calculate entropy changes for the reactions by the formula gives free energy G and a spontaneity. A spontaneous process in an irreversible process and may only be reversed by some external agency. Entropy S is a measure of degree of randomness or disorder of the system. Del S is related with Q and T for reversible reactions, as del S is equal to Q reversible upon T. The total entropy change for the system and surrounding of a spontaneous process is given by del S total is equal to del S system plus del S surrounding greater than 0. When a system is in equilibrium, the entropy is maximum and the change in entropy del S is equal to 0. The entropy for a spontaneous process increase till it reaches maximum, and at equilibrium the change in entropy is 0. The change in entropy for a reversible process given as del S system is equal to Q system reversible upon T. Entropy changes during the phase transformations are del S fusion S is equal to del fusion H upon Tm, del vapor S is equal to del vapor H upon Tb, where Tm is the melting point, Tb is the boiling point, and T is the temperature at which sublimation occurs. Del R S naught is equal to summations S naught products minus summations S naught reactants gives free energy. G is the net energy available to do useful work and is a measure of the free energy. G is equal to H minus Ts, a standard free energy of reactions. Del R G naught is equal to summations del F G naught product minus summation del F G naught reactants. Reactants gives Helmholtz reaction equations. Del G is equal to del H minus T del S. Del G naught is equal to del H naught minus T del S naught. Del G naught is equal to minus N F E naught, where E naught is a standard EMF of cell. Gives energy and a spontaneity. Del G gives a criteria for a spontaneity at constant pressure and temperature. If del G is smaller than 0, then process is spontaneous. If del G greater than 0, then process is non-spontaneous. If del G is equal to 0, process is in equilibrium.